Hello everybody. Today we're going to learn how to do vector problems. I like to use rip currents as an example because I grew up near the beach and I think it's something that's important for everybody to know about. A rip current is a very strong current of water that pulls people away from the beach out towards the ocean. They can be very dangerous. So I like to talk about them to make certain people know what they are, how to recognize them, and how to get away from them. So in this particular case, I have the beach drawn at the bottom of my board, and I have my rip current flowing north at 10 meters per second. Surfers like to use rip currents. They use the rip current as an easy way to get out towards the deep water. So a surfer might be on their board traveling at, I don't know, I'm going to make up a number. I'm going to say that the surfer is moving at 3 meters per second to the north. So the surfer is lying on their board and they are paddling north inside the rip current. I didn't draw the arrow inside the current just because then it would be on top of the other arrow and it would be hard to see. So I just drew it next to it. So how fast is this surfer actually going to be traveling? Well, when both vectors are going the same direction, we're going to add. So in this case, we're going to have 3 meters per second plus 10 meters per second gives us 13 meters per second. They're both going north, so the direction of our answer is going to be north. You have to give the number, the magnitude. Make sure you use units. In this case, it's meters per second. And make certain you give the direction. In this case, they're both going north, so our final direction is going to be north. Anytime the vectors are both going in the same direction, so when they are going in the same direction, we are always going to add. And you might want to write that down. Just put a little note for yourself somewhere so that you can remember it. All right, well, that's great for the surfers. They can get out to the deep water more easily. The problem with rip currents comes when we have swimmers who get caught into the rip current. So let's say we have a swimmer who is getting rapidly pulled out to the ocean and they want to come back towards the beach. So our swimmer is traveling, they are swimming back towards the beach. They're fighting the rip current. And let's say that they're really strong. Let's say that they are swimming at 5 meters per second. What's going to happen? Well, in this case, the two vectors are traveling in opposite directions, so we're going to subtract. You should probably add that to the note you made earlier. When they are traveling in opposite directions, you subtract. So I'm going to pick the bigger number, 10, and I'm going to subtract the smaller number, 5. Well, that gives us 5 meters per second. What direction is it going? It's going to be the larger vector. So the swimmer was traveling south, the rip current was traveling north, but the rip current is stronger. So the final direction is going to be the direction of the bigger vector, 5 meters per second to the north. So our swimmer is trying to get back to the beach, but the rip current is still pulling them out towards the ocean because the rip current is stronger. Now I know some of you are probably saying, hey, I'm really strong. I believe you. You probably are. But you're not stronger than the ocean. The ocean's bigger and it's stronger. The ocean's going to win. If you try to fight a rip current, you're going to lose, and then you get tired, and that's how people drown and that's how people die. It's really unfortunate. So let's learn what to do if you are ever caught in a rip current. The advice that everybody gives you is to swim parallel to shore. So you are going to swim this way, or you could swim east. I just picked a direction. So let's say that this person is swimming west. Now, it's the same person. They are still swimming at 5 meters per second, but this time they're traveling west. See, the reason you do this is that rip currents aren't very wide, and you're going to swim until you get out of the rip current, and then you can go back into the shore. Now you're not fighting the rip current, so now you're strong enough to come back. Let's figure out what happens here. You are swimming this way. The rip current is still pulling you out to the ocean. So you're going to swim, and the rip current's still going to pull you. So you're going to travel sort of like that. Well, if you look at this, this is a right triangle, or at least it's supposed to be I didn't draw my arrow very straight, so let's pretend that I drew that arrow straight. Okay, so this is a right triangle, and this black line here, the distance of that, that's the hypotenuse of the right triangle. And if you remember math class, when we need to find the hypotenuse of a right triangle, we use the Pythagorean theorem. So when your vectors form a right triangle, you're going to use the Pythagorean theorem. I have a lot of my students who call it, they abbreviate, they call it the P theorem. That's good enough. You know what you mean, I know what you mean. As long as you can use it, that's fine. I don't care if you know the full name. The Pythagorean theorem says a squared plus b squared, those are the two sides, those are your two component vectors, equals c squared. That's your long hypotenuse side, that's your resultant. So I'm going to pick one of my two components. It doesn't really matter which one. I'm going to pick this one and I'm going to call this A. So A equals 10 meters per second to the north. And I'm going to call this one up here B. So B is going to be 5 meters per second to the west. So when I do the Pythagorean theorem, I say A squared, well that's 10 squared, plus B squared, that's 5 squared. That equals c squared. Okay. 10 squared, that's 100. All right, there's a squared button on your calculator. Go ahead and use it. 5 squared, that's 25. Again, you can just use the squared button on your calculator. All right, and that equals c squared. So we have 100 plus 25, well that's 125 equals c squared. But we don't want c squared, we want c. So what we're going to have to do is we're going to take the square root of 125, and that's going to give us c. You can't do this in your head. Don't try. Go ahead and use the calculator. There is a button on your calculator that looks like this weird little symbol. That's the square root sign. So I do the square root sign, and then I put in 125. I hit equals, and the answer I got was 11.180333989. But remember, in physics class, we always round to the hundredths place. So my answer is going to be 11.1. This might stay an 8, or it might go up to a 9. So I look at the number after it. Oh, that's really low. So this is going to stay an 8. I always give my unit, meters per second, and I always give my direction. Well, when we have vectors that are at right angles to each other, you kind of mush the directions together. So we had north and we had west, so the direction is northwest. Let's go ahead and do another one of those. We're not going to do a huge number of these problems in physics, but these are the problems that most people think are a little bit difficult. So we're going to go ahead and practice one more of those right angle vectors. Let's say that we have a vector that is 8 meters per second to the east. And then let's say we have a vector that is, I'm going to say 4 meters per second to the south. The Pythagorean theorem says a squared plus b squared equals c squared. I'm just going to pick one of these. It doesn't matter which one you pick. I'm going to pick the 8 because I feel like it. And I'm going to call that a. So I'm going to say that's 8 squared. Plus, I'm going to call this one b. 4 squared equals c squared. Okay, so grab your calculator. 8 squared. I pushed the wrong button. Oops. Okay, 8 squared equals 64. Plus 4 squared is 16. And then I'm going to add 64 plus 16. That gives me 80 equals c squared. But I want c. So I have to take the square root. So now I'm going to say square root of 80 equals 8.944279191. I'm going to round to the hundredths place. 8.94. I'm going to give my unit, meters per second, and my direction is going to be southeast. And it's usually a good idea to put a box around your answer that makes it a little bit easier to see. I hope that helps you figure out how to do vector problems. Thank you.